But Tony, I am teaching, so you gotta find a seat and chill. All right. Okay, let's go ahead and get started. Okay, so today we're still doing derivatives, but we're doing applications. So stuff like tangent lines, horizontal tangents, vertical tangents, blah, blah, blah. So take a look at this first one. You'll notice all your X and Y stuff is on the same side. If you take the derivative of something with a Y in it, what are you going to have to add to the end? First period, we just did this today. dy dx. Do any of these terms need a special rule? First one, what rule does it need? Product rule. Very good. So your u is an x, your v is a y squared. And then remember, for product rule, you take the derivative of each piece, do the diagonals plus to the middle. So just in x by itself, what's u prime? V prime? 2y dy dx. Very good. Okay, then remember, as I'm taking the derivative, it's one plus the other. Since you're adding, though, it doesn't matter which one comes first. So I'm going to do the easier looking one first. And then the x 2y dy dx second. Okay, now remember, that expression is just the derivative of the xy squared. Next, I have a minus 2y cubed. What's the derivative of the next term? It's negative 6y squared what? dy dx. Okay, my next term is a 4x. What's the derivative? Just a 4. And then on the other side, it was an 8. Derivative goes to 0. Remember, anything that does not have a dy dx got to go to the other side. So what terms are we pushing across? Y squared and the 4. So it's now going to be a minus y squared and a minus 4. Out of the remaining terms, you'll notice that both of them have a dy dx. That means I can factor that out to the front. So I'm going to have my dy dx here. That's going to leave me with a 2xy from the first term and a minus 6y squared from the second term. Okay, then remember, to get your dy dx by itself, you're just going to divide that to the bottom. So it'd be 2xy minus 6y squared, 2xy minus 6y squared. Now remember, this crack that you just found is the instantaneous rate of change. Oh, are you turning it in? You just put it on my desk. Okay, this is the instantaneous rate of change, which is just a fancy way of saying it's the derivative. Okay, so instantaneous rate of change and derivative are the exact same thing. Okay, part B, I want to find the slope of the line where my y is a 0. But notice they already gave me that point right here. So dy dx, vertical line, 2, 0. Okay, remember, especially if it's a free response, you want to label stuff as you go. Okay, we're plugging in. It'd be a negative 0 squared minus 4 over a 2xy minus 6y squared. Top of that's going to come out to a what? Negative 4 over on bottom, 2 times 2 times, uh-oh. That would be 0, yeah? Dang. Okay, that means that it's an undefined slope. Okay, and remember, for an undefined slope, that's where you get a 0 only on the bottom. Okay, so remember, it's okay, no, and do more. Okay? Next question says, find any places where the tangent to the line tangent to the curve is horizontal. What part do I set equal for a horizontal, the top or the bottom? Set the top equal to 0. Now, what would happen if I set the bottom equal to 0? What would I get? An undefined or a vertical. Okay, so remember, vertical, you're letting the bottom equal 0. Horizontal, you're letting the top equal 0. So the top of my equation is negative y squared minus 4 equal to 0. Okay, first thing we're going to do is add that 4 across. So I have negative y squared equals 4. And then to get rid of that negative, I'm going to divide by negative 1 on both sides, which means that my y squared is equal to a minus 4. And then last step, to get rid of the square, do the what? Square root. Now, technically, can you square root a negative 4? So that would have no solutions. And so in this case, you would say, I don't have any places where my slope is horizontal. Okay, technically, you can get plus or minus 2i, but you don't have any imaginaries on this test, so you don't have to worry about that. Okay?
Can you imagine if you place on the grass?
I love you, but no. Okay, go to number 2. Go ahead and take the derivative, please. So it's 2y plus 4 cosine y equal to x plus 2. What's the derivative? Start with the 2y. 2 dy dx. What's the derivative of positive cosine? Negative 4 sine. That's it? Dy dx. Okay, and then the derivative of x plus 2 would give me just okay, remember that for your plus 2, that would just go to 0. Okay, then from there, I don't have any terms to push across because both of these have a dy dx. Okay, then I can GCF that out to the front. And what would be left over in that parentheses? 2 minus 4 sine y equal to 1. Very good. Then I'm going to take that parentheses, divide it to the bottom. Okay, remember that the expression you just wrote, that's the instantaneous rate of change. Instantaneous rate of change, which is just a fancy way of saying that's the derivative. Okay, and then remember, the derivative can be used to find the slope at any point that you want. You would just have to plug it in. Okay, if I want my tangent line to be vertical, what part of the fraction do I set equal to 0? Bottom, very good. So for a vertical tangent, we're going to set the bottom equal to 0. So I have a 2 minus 4 sine y equal to 0. What should I do first? Minus the 2 across. That gives me negative 4 sine y equals negative 2. Next step. What is negative 2 divided by a negative 4? It'd be 1/2. Very good. Okay, now this is where you're going to have to think about what angle would this have to be so that my sine would equal 1/2. So look at your hand. Where are my sine fingers supposed to be, top or bottom? Bottom. So I want to leave one finger on bottom, hold the next finger. So what angle do I want for my answer? Pi 6. Very good. So my y is going to equal pi 6. Now, we really haven't done a ton of this, but there are actually 2 places on the circle. Because do you see right here that it says from 0 to 2 pi? So if this was multiple choice, they would only list this answer. But if I want to consider the entire circle, draw me a little unit circle here. Okay, at pi 6, I want it. And remember, pi 6 is the y value. So in which other quadrant, 1, 2, 3, or 4, would my y value also be positive? 2. So I want to know what this is. Okay, well, all the way across the top half of the circle is 1 full pi. So this would be 6 pi 6. So if I just want to reverse back one of those, what would my second answer be? 5 pi 6. Okay, so really that one would have 2 answers. Okay, but if you got the first answer, you would still get partial credit if it was a free response. Okay. but only if it lists the entire circle would you have to worry about repetition answers. Okay? All right, go ahead and turn the page. Let's go to, let's do the next one. Okay, so it tells you dy dx is 3x e to the 4y. They're asking me to find d squared y dx squared. What do they want us to do? Take the derivative once or twice? Normally it would be twice, but what did they give me? They already gave me the first derivative, so I'm taking it how many times? Only once more. So what rule am I going to need to take the derivative of this? It is product rule. Very good. So my u is going to be a 3x. My v is an e to the 4y. Then I'm going to take the derivative of both of those parts. Remember, it's a cross product for product rule. So my u prime, the derivative of 3x is just a 3. What's the derivative of e to the 4y? E to the 4y. I am going to have a dy dx, but what else am I missing? Times 4. Because remember, chain rule says if it's not just an e to the x, you have to multiply by the derivative of that exponent. So 4y would give me an extra 4 and a dy dx. Okay, let's write our second derivative. Say that again. No, not e is like a special. Okay, so from there, it's going to be this plus this. So 3e to the 4y plus. And then for my other diagonal, let's go ahead and do a little bit of the work. What is the 3x times the 4 going to give me? A 12x. So it'd be 12x e to the 4y and then dy dx. Now, I want to find the value of this when x is what? 2. Okay, unfortunately, I can't just have an x. I need an x and a y. So where did they tell me the y that goes with 2? Right here, very good. Okay, my ordered pair is going to be 2, 0. Okay, now look at that equation. I know my x is a 2, my y is a 0. What else am I going to need a number to plug into? The dy dx. Very good, right here. How am I going to find dy dx? Remember, they gave you an equation for that. So let's real quick find our dy dx at 2, 0. And remember, this is the derivative they started me out with, so I'm just subbing into it. So it was a 3x is now a 3 times 2 times e to the 4y, which is now a 4 times 0. What's e to the 0? 1 times 3 times 2, 6. So when I plug in, my x is a 2, my y is a 6, and what will my dy dx go in as? I think I said that wrong, but you know what I mean. 2 is my x, 0 is my y, 6 is my dy dx, and then we're plugging in. So it'd be 3e to the 4 times 0, 12 times 2, e to the 4 times 0, and then this guy's a 6. E to the 0 is what? So both of these are just a 1, and I have 3 plus 2 times 6 is 12 times another 12 would be 144. So it'd be 147. Okay. But remember, if you're taking the second derivative, the dy dx spot is just going to be whatever your answer was for dy. Make sense? All right. Uh-huh. Because you're taking the derivative of x and y stuff that's multiplied. So like, let's say it was 3x divided by e to the 4y, then you'd be doing quotient rule. Okay. All right, let's take a look at the next one. Okay, it says, I want to find h prime. What type of function is this called? Do you remember? Where it's in multiple pieces, piecewise function. And remember, in order for the derivative at 0 to exist, the left and right derivatives have to match each other. So right here, let's take our function h and let's find h prime. Now remember, for a piecewise, you're just taking the derivative of the different pieces. So for the top piece, it was an x4 plus 3x. What's the derivative of that? Plus 3. And then on the bottom, what would my derivative be? So e to the 3x would be e to the 3x again, but then because of chain rule, I would times what to the front? A 3. And then what happens to my 5 goes to 0. So this is for x is less than or equal to 0. This is for x is greater than 0. Okay, now, in order for this derivative to exist, the derivative has to be the same on both sides. So I'm going to check the limit from the left. I'm going to check the limit from the right and make sure that they equal each other. So write down limit x approach 0 from the left on h prime. Then we're going to check the limit as x approaches 0 from the right on h prime. Remember that approaching 0 from the left means you're approaching it from x's that are on the less than side of 0. What part of the piecewise is that, top or bottom? Left would be top. So it'd be 4 times 0 cubed plus 3, which would be 3. So this is my left side slope. Okay, on the right side, we're plugging into the bottom. We'd have 3 times e to the 3 times 0. E to the 0 is 1. 3 times 1 gives me 3. So did my left and right side derivatives match? Yes. Okay, now there's one more tricky thing that I want to show you off of your little cheat sheet. In order for your derivative to exist, your graph has to be differentiable. So look right here on differentiability. What's the first step for differentiability? At the end, the slopes have to be the same. But what else has to be true? The graph has to be continuous. So have we checked that the original left and rights match each other? Not yet. So let's do it. So I see that my derivatives match. That's good. Okay, but in order for me to know that this is a correct answer, I have to make sure my graph is connected. So let's check the limit as x approaches 0 on regular h from the left. And then regular h from the right. Okay, on top, we're plugging in a 0. What are we going to get? So 0 to the 4 plus 3 times 0 is 0. On bottom, e to the 3 times 0 plus 5 gives me 6, because this would come out to a 1 plus 5 is 6. So based on my originals, is my graph continuous? Well, my left and right sides are different. Then if it's not continuous, it's automatically not differentiable, which means it doesn't even matter that these match. So your final answer would be that h is not continuous, therefore also not differentiable. You wouldn't have, if you show that the left side is 0 and the right side is 6, it's clear that they're not equal to each other. Okay, and then also look at the instructions, right? If they're saying if it doesn't exist, make sure you explain why. They're not putting that for no reason. So make sure you're kind of covering all your bases. Okay, but if it's not continuous, it can't be differentiable, which means you can't find the slope at that point. Okay, next little part of this, I want to do, we want to take the integral from -1 to 3. But you're going to notice that in order for me to do that, I'm going to have to break this up based on where the graph switches. Where is the break point on your equation? 0. So from -1 to 0, I'm going to use the x4 plus 3x. And then from 0 to 3, I'm gonna use the e to the 3x plus 5. Okay, and we didn't really do a ton of this, but think about it. If your graph switches at 0, then for you to compute that antiderivative, you would have to go from -1 to 0 on the function you're under. And then from 0 to 3, you'd have to go under that function. Okay? For this one, go ahead and take the antiderivative. What would it be? Simple power rule on this. X would go to the 5, then a 1/5. What would happen to my 3x? 3x squared over 2. And then remember, you're just going to take your endpoints, plug them in, and subtract. Now, if the top endpoint is a 0, we know that's just going to come out to a 0. On the bottom, I'm plugging in a -1. What is -1 if I raise it to the 5th power? Still minus or switches to a plus? Still minus. And then what is -1 if I plug it into a squared? Still negative or positive? Positive. So that's a +3/2. And then remember that it's top minus bottom. So if I do 0 minus these guys, my answer is going to come out as a +1/5 and a -3/2 for that piece. Okay, now you don't have to make these have the same common denominator, so don't even waste your time. Okay. For this one, what's the antiderivative of 5? 5x. Then I would plug in the 3 and the 0 and subtract. 5 times 3 is, because that one needs u sub. That's a great question. So I'm going to do the 5 first just because it's easy. So 5 would go to a 5x, which gives me 15 on top, 0 on bottom. What's 15 minus 0? 15. And then for this term, what Emily asked is, why did we skip it? E to the 3x is going to need what integration method? U sub. What's your u going to be? 3x. Which means your du dx is going to be a 3, which means you're going to replace your dx with a du over 3. And so for this term, it's going to be e to the u du over 3. And then what is the antiderivative of e to the u? One-third still e to the u. Because remember, e to the u is its own guy. Can I use the original endpoints for u sub? You got to plug them into what your u was. So if my u's at 3x, what's my new top number? 9, what's my new bottom number? 0. So I'd have a third e to the 9 minus a third e to the 0, which would just be a third. Okay, so for that one, you'd actually end up having to break it up into 3 pieces. Okay, this one's chill, the 5 is chill, but the e to the 3x in the middle, you got to do u sub on it. Okay? All right, pull out your sheets. Good job. Your session was derivatives and their applications, I think. So you can just put derivatives and apps. You go to that black crate by the door, and it's the very first thing. Yesterday was. We have the package. Yeah. Hang on one sec. Did I get everyone? Of course. It's Aaron, wow. Y'all put your name on these. Like she's really on vibrant and I yes, they're little chocolate. I don't think it's there.
Here's Ayla, right?
I'm so happy with it. I have all my work done except for that, like, I don't have it, but I don't have to do it. It's paid out by.